Hello, let's do the New York Times hard Sudoku for September 22nd, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, we got 1, 2, 4, 5 here. The one's in one of these two in this box. Not seeing anything else to do with ones. The twos buddy up here. This 2 helps, puts a 2 in one of these two. Vertically, no, nothing. We got the 4s here. That does place the 4 in this box. All right. I'm not seeing more follow-up there. I mean, this box is down to 4, but we'll get there. We have 2 5s here. This 5 looks up, putting a 5 in one of these two. These 2 5s look down, putting a 5 in one of these two. All right, so when we mark these 5s, something to look for is, okay, well, where's the 5 in this row then? Because we know in this box, the 5 is only in these 2 rows right here. And so the 5's not here. The 5's not where this 1 is. And we can look up to see how the columns are working. This 5 looks down. This 5 looks down. This 5 looks down. So there are only 2 places left in this row that can be 5. And it happens to be in the same box. So this is going to do what's called claiming, where this row needs a 5. The 5 ends up here or here. Wherever it ends up, that's also the 5 for box 9, meaning the rest of box 9 can't be a 5. So specifically, we learned, if we were talking about eliminations, we've eliminated 5 from these two because the rest of them already couldn't be 5. While we're at it, these 2 5s look down, putting a 5 one of these. Oops, putting a 5 one of these two. So is there anything immediate to learn about these two not being 5? 2, 3, 4, 5. Not really. All right. We'll just have to remind ourselves with these corner marks later. Okay, back up to here. We did do the 5. Does anything look into this box that might be interesting? Yes. So yeah, we got our standard, what's called the New York Times trick. I'll do it this way. So we've got 1, 4, and 5 here. I'm going to mark that in green. And we've got 6, 8, and 9 here. I'm going to mark that in purple. So this is kind of a pattern to look for in a lot of New York Times puzzles. It appears a lot. Not every puzzle, but maybe 1 and 3. Anyway, so these 3 green digits here, 1, 4, and 5, they need to appear somewhere in this column, and they do not go in this box. But we also have in this column, we have these 3 purple givens, the 6, 8, 9. And importantly, none of the purple digits are the same as the green digits. So we need to put the green digits somewhere in this column, but they're not going to repeat in the box, and they're not going to go where these purple digits are. And so those green digits have to go in these 3 cells. There's the only 3 cells that can have the green digits, and there's 3 green digits. So that's what they are. And so these end up being 1, 4, 5. Now this can't be a 5, so it's 1, 4. And these are 1, 4, 5. Now what's happened there is we have eliminated any other digit that we thought could be there. And then we can call these the blue digits. Those are the remaining 3 digits that aren't green or purple. And so that's going to be the 2 as well as the 3 and the 7. Now this 7 looks in, so that's 3 and that's 7. And so now these in this box, you notice we have the 3 greens and the 3 purples. So we need the 3 greens and the 3 blues. So we need the 3 purple digits. And so this is going to be 6, 8, 9. And this can't be 8 or 9. So that ends up being a 6, leaving an 8, 9 pair behind. All right. So that's generally what you get out of, we got a little lucky with some place digits, but it's generally what you get out of the New York Times trick is you get to place the hidden triple, you place this triple, and you place this triple inside the box as well. That's always going to happen when you have that situation. So just know how to follow up on that. I'm going to remove the colors now. So we just got a bunch of digits up here, so we're going to rescan. So the 3 does look in here. These all aren't 3, so the 3 is in one of these 2. That points in here with this 3. This 3 looks up. 3 in one of these 2, but also this is just a triple, so let's fill it out. It's the 3, 6, 8. These 2 8s look in, so this is our 8. And this is a 3, 6 pair. Don't need the corner mark. Okay, so that was 3. We also got the 6. These 2 6s look in. Puts a 6 somewhere here. 6 looks in here, putting a 6 in one of these 2. We already have the 6 over here. And the 7s. 7 is placed in the box. Very nice. That follow up on that, putting a 7 in one of these 2. Okay. We have this 8, 9 pair, but we already have all our 8, 9s. Okay. So that 8, 9 pair has been there, but we kind of got it for free by finding the New York Times trick, the hidden triple. All right, this box here, we are down to 1, 3, 6, 8. I don't think there's any 8s looking in. So all of these are just the corner marks plus an 8. All right. This row is down to 1, 3, 8, 9. This is not an 8. So it's 1, 3, 9. Oh, it's not a 3 either because of the 3, 6 pair. This box is down to 1, 2, 5, 9. So this is 1, 5, 9 because it's not 2. This is 1, 2, 9 because it's not 5. This could be any of them. So I'm not going to mark it. All right. Did I get anything else that needs to be followed up on? The 4 maybe? All right. Let's make sure we catch all the verticals. We got the 5. The 9s look down and in, putting a 9 in one of these two. The 5s, the 7. I don't think there's anything else with this box. How about this box, the 4, 7, 8? I don't think so. All right, this column is down to 3 digits. Let's just take a look. We need a 2, 3, 7. So I'm seeing the top one's not 7. This one's not 3. Let's just write it out. Remove the 3 and the 7. Okay, so let's look at this box. We have the 5s done. We have the 8s and the 9s. The 8s look in, putting an 8 in one of these two. We do want to look in this column for 8, but it can be down here as well as up here, so no good. And then we have the 2 9s looking in. That does place 9 in this box. That gives us the 1 up here. This is now a 3, 8 pair, so this is the only place for 9 in the row. That's an 8. We get the 6 and the 1 here. These are no longer 1s. In fact, this is just 2, 5, 9. It's not a 9. Okay, so that got very clean. We got the 8, we got the 9, we got some, what else did we get here? The 1 and the 6. So the 1s look in, putting in one of these two. I don't know that the 6 does anything, does it? Not that I see. All right, 5, 8, 9. So that was just from placing this 9 here. 5, 9, 9, 9. This box, we have 5 and 9. This box, 3, 5, 7, 8, 9. All right, I want to look at this box. It has 4 digits left. We know one of them is a 2, and this 2 looks in, putting a 2 in one of these two. So that's going to point. Is there anything I can do about that? No, I mean, so the pointing is telling us that none of these are 2 anymore, because the 2's over here, so it can't also be over here. But I don't have anything really to mark for that, so I'll have to remember. The rest of, excuse me, the rest of this box is 1, 2, 4, 6. The 4 also looks in. So we can corner mark the 4s, and that does pointing for us. That'll make that a 1, et cetera, et cetera. But before we do that, what we should notice is that we have actually overlapped the 2 and the 4 corner mark exactly. There are 2 cells in this box, and we need to place a 2 and a 4 in those cells. So therefore, one of them is a 2 and the other is a 4. Gives us a hidden 2-4 pair. And so nothing else can go in these two. So the other 2 digits are here. These are the 1 and the 6. And so that's a 1-6 pair as well. This is now down to 5, 7, 9. Because they can't be 1-6 anymore. This one looks down. The 1-6 pair points down. This is 1 looks in. So sorry, the 1's in one of these two. 2-4 pair does make this a 1. So this is now a 4-5 pair. The 1 comes back, giving us the 6 and the 1. Placing the 1 in this box as well. Rest of this row is a 3, 7, 8. We know that's not 8, so it's 3, 7. This one's not 7, so it's 3, 3, 8. This is 3, 7, 8. This is a 2, 3, 7 naked triple. So if you think about it, this cell can be 2, 3. This cell can be 2, 7. This cell can be 3, 7. So between these 3 cells, we know they're all in the same box. So we can't repeat a digit. We can't make this a 3 and this a 3. So we need 3 distinct digits in green. What digits can we put in green? Well, this cell can only be 2, 3. This cell can only be 2, 7. This cell can only be 3, 7. So the only digits I mentioned are the 2, 3, and 7. And so I need to use up all of 2, 3, 7 in green, meaning I can't put any more of those green digits outside of the box. So this ends up being a pair. And if we were to look, it would actually also be a hidden pair that we could do that logic as well. But it is a 4, 6. And if you think about it, we do need to put 4 and 6 somewhere in this box, and they can't go in any of these cells. We have this 4, 6 looking down. We have this 6 looking in along with the 2, 4 pair. And so ultimately, you're always going to have 2 sides of the same coin. You're going to have the naked and the hidden. So in this case, because there were 5 cells left, they're going to add to 5. So we have the naked triple, which is 3, and then the hidden pair, which is 2, and they add to 5. you're always going to find like the logic is complementary and does the same thing. The other thing I'm noticing is that the 2 in this box ends up in one of these two, which is going to point down, telling us that's not a 2. Now the 4-6 pair does look down. I don't know how this. I somehow got rid of the 5. Oh, I got rid of the 5 center mark instead of the corner mark. Not a big deal. Oh, remember we had these corner mark 5s, and I said I really need to remember that, and I didn't. So that's not a 5. Doesn't really do anything yet, but right. I wanted to look at these digits because this is 3-7. So, and this is a 4-5 pair. So we need a 1, 2, 3, 7. So I'm seeing that I can mark these because that's not 1, that's not 2. I think this can be any of them. But the other thing to note is that the 2's one of these two, the 1's one of these two. I don't really think we need to mark that. I think it's extraneous at this point. All right, let's go back up here where we were looking earlier. So let's just do the rows here. So we need 2, 3, 4, 6 here. So this is 3, 4, 6, not a 6 actually. 2, 3, 4, 6. And then this row we need 2, 4, 6, 7. Again, this is not 2, 6. Okay, so 2, 6 looks in. This 6 looks in along with the 2, 4 pair. So we have a hidden 2, 6 pair here. And so this is 3, 4, 7, 8. Not a 3. 4. Whoa, what's happening? 4, 7, 8. Oh, it's not. Oh, shoot, it's not 8 either. 4, 7 only. There we go. I got it. First try. Okay. This is a 2, 6 pair, so let's look at the rest of this column. We need a 3, 4, 7, 8. It's not an 8. So, oh, these two aren't 8. So these are 3, 4, 7. This can be any of them. I'm clearly not looking in the right place. It feels like there's just like one little deduction to get, and we'll be done with this puzzle. 2, 4, 2, 6. Okay, well, let's just scan. Maybe there's something we haven't scanned here. You have these 8s. That's really it. All right, I'm going to look more carefully here. I'm going to go row by row, and I'm going to make sure, do I have any pairs or triples? I'm also going to see if there's anything worth penciling as I go row by row. So what's interesting is we do have this quad, and they're like primed to collapse, right? Two digits each. But none of them match. 4, 6, 2, 3, 3, 4, 2, 6. So we can't resolve it on its own. Same here. 4, 6, 2, 7, 4, 7, 2, 6. They're all different. So each digit appears twice. Down here we have the 3, 7, 8. We already marked the 8s. All right. Anything going on here that might be interesting? Yes, this is a 3, 8 pair. So this is going to be a triple. I'm sure that's going to be helpful. We know one of them's a 9. And since it's a triple, I'm going to... Did I have... Oh, I had 9, 9, 8 marked. Sorry. Let's just think. Oh, so that's not an 8. But anyway, 9's here. What else do we have? 2, not the 3. Okay, so this is a hidden 2, 9 pair for the column. What's the other digit we need? We need the 6. So this is where the 6 goes. But here, let's just show what happened here. This is a naked 6. Because it can't be 1, 2. It can't be 3 because the 3, 8 pair. It can't be 4 because of the 4 on the column. Can't be 5. Can be 6, and it is a 6. Can't be 7. And then the 8 is part of the 3, 8 pair, and then 9 is in the row. So the only digit it can be is 6, so it must be, and so that's another way to see that. Might be a little easier to see it as the naked single rather than the hidden pair. Okay, so I got this 6. These two 6s look in. There's now only one place for 6 in this box, which now makes only one place for 1 in the box. This cannot be 1. That's a 3, 7 pair. Placing the 2 and the 1 here. That's 9 and 2. That's not a 9. Looks like we probably cracked it. That's 3, 6. I think 3 in this box just got limited. I guess it's just one of these two. What's this row doing? We need a 3, 4, 5, 7. This can't be 3, 5, or 7, so it is a naked 4, giving us 2 and 4, giving us 9, 5 and 2. We get the 7 here, that's 3. Okay, that places this 3. We get the 9. We get the 7 and 3. We get the 3. This whole row collapsed now, 2, 6, 4, 3, and that collapsed this as well, 6, 7, 4, 2. That's 8 and 7. That's a 4. We get the 8 and the 3 here. That's our 8. That's 5 and 4. That's a 5. That's a 5. That's a 7, and we're done. All right, cool. Yeah, I think spotting this Always nice to spot the New York Times trick. There were a few hidden pairs and stuff also that were very nice to spot. And then this naked six kind of came out of nowhere. But I mean, it was natural to pencil this column because we had the 3-8 pair here. So it was just these three. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.